Hello. In this video, so welcome back, and in this video we're going to talk about our first, for the first time, a distinction that will be important for the rest of the semester, but we will build this up to make it larger. So it's the first time we're going to see the words vector and scalar, and we're going to just see the first examples of each, and the distinctions between them. More importantly, what I'm going to try to do is relate the words that we've been using in class to everyday language. Specifically, I want to connect or relate the ideas of displacement and distance, or velocity versus speed. You could also say fast in there. When we say fast or slow, we really are talking about a speed concept. So, very good. So, we've already defined displacement. It's the change in position. And velocity is associated with a change in displacement per unit time. We've seen that before. So, I think the easiest way to do this is to go through an example, especially for displacement and distance. And then I think you'll see the issue. Okay? So, displacement, so that is the change in position. So let's say this is 0, and then I walk over here, say this is 1. Okay? So if I start here, and I finish here, I went in the positive direction to the right, so my displacement would be plus 1 meter. And the distance I traveled would be plus 1 meter. Now let's go backwards. When I went backwards, my displacement for the second part was negative 1 meters. But if I had an odometer or a measure something, if I measured the length of my trip, it would have been a plus 1. So say that again. When I went forward, my displacement is plus 1, and the distance I traveled would be plus 1. Now I'm going to go backwards. My displacement is negative 1, but the distance I traveled is still plus 1. Distances are always positive numbers, whereas displacements can be positive or negative. It can be even more complicated. What about this? I'm going to go through a complicated trip, and we'll try to keep track of it. Okay? So I'm going to go forward half, back half. Forward 1, back 1. Okay. Now, where did I start? Here. Where did I end? Here. What was the displacement, the change in position for the whole thing? Big fat 0. I didn't go anywhere. On the other hand, what about distance? I went forward half and then back half. So the distance would be half plus half is 1. Then I went forward 1, backwards 1. The distance would be 2. So it'd be 1 plus 2 for a total of 3 meters. So my distance in that trip was 3 meters. My displacement was 0. There's a difference. When I was in high school, I was kind of confused by this the first time I heard it, and then it kind of hit me all of a sudden. When you're talking about displacement and distance, the way to think of it is, imagine you get in a car trip and you're on going through some mountainous path, okay, or on a road, and the car's, it's winding in and out and up and down, whatever, doing its thing, and the distance would be associated with the number of turns, as far how many turns the tire made, so how far it was. Or if you were to take a rope and kind of wind and kind of wrap it around the path, how much rope would it take to follow your path? That would be your distance. Displacement is only about the beginning and ending points. It's when people talk about as the crow flies. You just kind of went straight from beginning to end, forgetting all the details. That would be displacement. Okay, so that's the difference between displacement and distance. what you'll notice is they're very similar. It's just that when you have distance, I didn't worry about the minus signs. You only counted the positive amounts for distance. Okay. And that really gets at the true difference between these concepts. Vectors are quantities which know about not only the size, but which direction in the world you're traveling. Whereas scalars don't know about the orientation in the world. So, for example, there's a difference. My displacement is different if I move to the right or to the left. My displacement is different. One was positive, one was negative. But physically we know there's a difference, right? It's like the difference between being in front of the car or behind the car, you know. It's a big difference. One you get hit and one you don't. But the distance didn't care about whether I was moving forwards or backwards. It was just the size. It was just the magnitude or just a number. Scalar quantities don't know about orientation in space. Vector quantities do. So for right now, displacement is a vector. Distance is a scalar. There are many other quantities. Temperature. Temperature is a scalar. Your temperature doesn't matter, doesn't care if the temperature here doesn't matter if I look at it from one side or the other, it's the same. Same way with mass. My mass is what it is. If I turn around, it doesn't change. It doesn't matter which way the scale is oriented. My mass is my mass, for better or mostly worse. Mass is a scalar. All right. So vectors and scalars are it's an important concept. We will come back to it over and over throughout the semester, and hopefully it'll be clear. It will be clear as we learn more, and we will enlarge upon these ideas when we get to 2 dimensions or even 3 dimensions. How it works then, but it's really the same basic distinction. Vectors have a magnitude and they know about the direction in space. Scalars only have a number. They don't care about orientation and things like that. So let's kind of do the same thing I did there, but on the board. So let's say we had a path and we started here at x equals 0, and then we walked over here, and then back, and then ended up here. So let's say this was, maybe make it a little easier here. Let's say this is at x equals 1. We'll say this is x equals 3. So in that case, the displacement, delta x, would be, well, final minus initial. I finished at 1. I started at 0. That would be 1 meter. I'm doing these in meters. What about the distance traveled? Well, that's the length of the rope that you would kind of lay out behind you, or a ribbon that follows wherever you go. So the distance would be 3, back 2, now I'm up to 5, forward 2, now I'm up to 7, back 2, I'm at 9. Distance is, I don't know how to, whatever, it's 9 meters. The length of the ribbon would kind of follow behind you. Okay? Displacement and distance, that's the difference. Hopefully that's okay. What about velocity and speed? Velocity we've already seen. Velocity is the rate of change of position, or the rate of change of displacement, same thing. And so because changes in position are different, whether you're going forwards or backwards, they know about orientation in space. So velocity knows about orientation in space. And later on, we'll see the difference between, you can have a velocity to the right, a velocity up, a velocity forward, or any other direction. Those are all different velocities. Velocity knows about direction. So velocity has a size, big or small velocity, and it has a direction. It's a vector. Speed, on the other hand, will be just a number. So if you're in a car, you have a speedometer, and it deflects. And you can be big, you can go faster, you can go slow. But when you are, but the speedometer doesn't care whether the road is taking you north or south or east or west. It just reads the same. So that what you see on a speedometer is a speed. It's a scalar quantity. It doesn't know about direction. So speed is going to be a scalar. More precisely, they are defined as follows. We have something called an average speed. And I'll just write it like that. Average speed, that is simply the distance traveled, the total distance, not displacement, divided by the total time over some interval. So you have some beginning and so total the distance traveled over the time traveled. That's the definition of the average speed. And then we have another concept of speed, which is the instantaneous speed, which is usually what people mean when they say your speed, because they want to mean your speed right now, in an instant. Your instantaneous speed is defined as the magnitude or size of your velocity. So it's the part of velocity which is associated with big or small, not the orientation. So if you're traveling with a velocity of 5 meters per second to the right, your speed is 5 meters per second. If you're traveling at negative 5 meters per second, so 5 meters per second to the left, your velocity, your speed is 5 meters per second. It doesn't care about the minus sign. It's just the size of the number, or size of the quantity, size of the vector. It's a better way to say it. When we get to 2 or 3 dimensions, these words are correct. We have to change, we have to be a little bit more careful to define the magnitude of the velocity in 2 dimensions or in more dimensions. But the idea is correct, that speed will be the size of the velocity. So it's kind of the information, when you forget about direction, it's whatever's left behind. That's what speed is. Whereas velocity knows about speed and direction. So velocities are more. Vector quantities contain more information than scalar quantities, typically. Actually, always. So, and the laws of nature are naturally expressed using vector quantities because right versus left is important for nature. So it's going to be expressed in terms of vectors. And that's why the equations we get and all of the concepts that we will use will not directly involve scalar quantities. After the fact, you can massage the equations or massage the ideas into scalar quantities, but that's not the natural way to write things. And so the natural way will involve vector quantities. Okay, so that is our video on vectors and scalars. As part 1, we'll have many more as we develop these ideas. And our examples were displacement, distance, or velocity versus speed. All right, see you next time.